Good morning, everyone. Today we will be continuing this specific PowerPoint that we had before. So this is our first PowerPoint presentation in general chemistry. We already tackled about chemical formula, chemical equation, the different symbols and their uses, as well as how we are able to know the different and probable oxidation states for each and every element, ion, and even compounds. So for today, we will be talking about the 5 types of chemical reactions, namely combustion, synthesis, decomposition, single displacement, and double displacement. First and foremost, what is chemical reaction? A chemical reaction is a process that leads to the chemical transformation of one set of chemical substances to another. So it involves transformation. There is an evolution or a change that is happening when there is what we call chemical reaction. Let's go first to synthesis, and in some other books, this is known as combination reaction. It is where a single substance is being formed or produced by the union of two or even more substances. So the general rule that we follow in synthesis or combination reaction is just simply substance A plus substance B will yield or form product AB. Okay, so there is a formation of a single substance by the combination or the union of these two substances here. So let's take, for example, we have lithium and iodine. So of course, in order for us to write the chemical formula, we have to know first the different oxidation states that they have. But then again, let me emphasize to you that in talking about chemical reactions, you will not be dealing with how you are able to really write a chemical reaction. Okay, what I need you to focus on is just really how to analyze what this specific reaction is presented to you. Okay? So amo lang tinada ang aton nga gina-focusan, hindi na kita ya magsulat mismo sang aton nga chemical reaction. If you are presented with this type of equation or chemical reaction, you'll just be able to focus more on determining what type of reaction this is. Okay, so if ever you see this general rule, A plus B will yield AB, then that will refer to synthesis or combination reaction. All right, are we clear with that? So just going back to our oxidation state, we have here for lithium that is +1, having a +1 oxidation state, and for iodine, we have -1. So the cation here is written first, that would be lithium, and next is the anion. Okay, so if you crisscross method, these two oxidation states, both of them will have a subscript of 1. Am I correct? Okay, so here we first write the cation or the positive ion, which is lithium, and then followed by the anion, which is the iodine. Iodine is the non-metal here. Okay, so first check the algebraic sum of the oxidation numbers for the reactants before writing the produced compound. But again, you will not be the one to assign oxidation states. It is already given in the formula. Okay, let's continue. Next is the decomposition reaction. So decomposition reaction, from the name itself, it is decomposing. So this is a reaction that involves using heat or electric current to separate the product to its reactants. So when we say decomposition, there is a separation. So it involves here one product, and then you will have to divide them or separate it to its reactants or its component. So it is the opposite of synthesis. The general rule that we follow in the composition reaction is AB, which is one product, and will yield A and B. Okay, so which means it has to go back. It's just like a reverse reaction, because from the product itself, which will become the reactant, and when you apply heat or electric current, you'll be able to separate it to its previous reactants, which will be in this specific reaction the products. Okay, so let's take for example H2O. H2O can be separated into hydrogen and oxygen by virtue of what we call electrolysis. So electrolysis is just simply applying electric current in order for us to separate H from O in the molecule of water. Okay, so that is just one of the common and very familiar decomposition reaction that is happening. And we also have here, let's take for example, CaCO3. CaCO3 is also known as calcium carbonate. In order for us to be able to separate calcium carbonate into CaO or calcium oxide and CO2 or carbon dioxide, then we'll just be able to apply heat. The triangle here will actually signify the application of heat. So if ever in some of the reactions that you can see, if you are able to encounter this triangle here, it actually indicates the usage of heat or the involvement of heat in the reaction. All right. So if ever you are asking how did CaCO3 become CaO and CO2, we still take regard or consider the oxidation state. So from the reactant here, so they are balanced in its oxidation state. Their algebraic sum is 0. If we ever try to divide it into its component parts, its different compounds that will be formed will also have an algebraic sum of 0. And the total mass will still be proportional with each other. Okay, anyways, you will not be focusing on that. If ever you are able to encounter this usage of electric current or heat, then the composition method or reaction has occurred. Are we clear? I hope so. Let's proceed to single displacement or replacement. Single displacement or replacement in some other books, it is where the possibility of the positive part of a compound or the cation part of a compound or the partially positive of a compound may interact with the negative part of another metal, or let's say, for example, non-metal. Okay? So the general rule, there are two general rules that we follow, especially when we apply it into metals and non-metals. For our general rule in metals, we have AB. This is a compound, which is an ionic compound that involves a cation and an ion. We have a metal and a non-metal, plus or combining with a C, which is a metal. Okay, this is another cation. So this cation has interacted with a compound that has both cations and anions, and it will yield Cb, meaning that the cation C will now interact or combine with the anion B, leaving A behind. No? So, digin B, linya lang. Inbuslanya, ganislanya ya partner, no, while leaving the other one behind. Okay, so A here is the cation. Okay, why does this happen? Later on, we will answer that question. So let's take, for example, we have calcium chloride plus potassium. So calcium chloride, calcium here is the metal, chloride or chlorine is the non-metal, potassium is the metal. Okay, so we have the chemical formula for calcium chloride, CaCl2 plus K. K is the symbol for potassium. It will yield KCl plus Ca. Okay, so why does this happen? Let's proceed to the next slide. This is because of the electrochemical series. This is the listing of chemical species like atoms, molecules, and ions in the order of their tendency to gain or lose electrons. So if they have the tendency to gain, they are being reduced. And if they lose electrons, they are being oxidized respectively. Okay? So here, in simpler term, amo ni siya ang pasunod. No? If it's a cation, they mostly lose electrons. Okay, so there are the sequence or order in terms of these ions, atoms, and molecules, in terms of their electropositivity. Okay, how positive or how much they lose electrons. So in the first among them is we have potassium. So see, potassium get very more electropositive. So it has the higher tendency to lose electrons, okay, to be transferred to another anion. Next is we have sodium. Next is calcium. Next is we have magnesium, aluminum, zinc. We have iron. Okay, we have tin, we have lead, we have hydrogen, copper, we have silver. Okay, so those are the sequence, no? Amo lang nandi siya ang given common nga mga elements or cations that we have. All right, but then there are so many pa. Okay, next here we have, this is with regards non-metals, because as later on we go back to our previous slide, we will be able to see that in single replacement or displacement, we are also dealing with non-metals. So this is naman ang pasunod or the sequence of elements, ions, or molecules which are more electronegative, meaning they have a higher tendency to gain electrons in their nuclear structure. Okay, so we have here the first one, which ang pinaka-electronegative is we have fluorine. It is much more electronegative than sulfur oxide. Okay, or this is what we call, I believe this is sulfate. Yes, that is SO4. That is sulfate. No? And we have nitrate. This is nitrate, NO3. And we have chlorine, bromine, iodine, and this is hydroxide. Okay? So, again, amo ni siya ang pasunod. Yeah. No, we always sort. No, the higher it is, it will be on the topmost part. Okay? And of course, going to the bottom. Now, mas less na ang electronegativity. Okay, so let's go back to the previous slide. And single displacement, this happens because of the electrochemical series of, or the order of our electropositive and electronegative metals and non-metals. All right, so in metals, we have here calcium chloride and potassium. So potassium is much more electropositive compared to calcium, as we have seen in our next slide. Okay, the electrochemical series, meaning chlorine, which is the anion, is much more attracted to potassium than it is attracted to calcium. That's why in the formation of the product, we have chlorine now interacting or being paired with potassium, leaving calcium behind as a single product. All right, so that's what happens in single displacement or replacement. Okay? Kung ginhimo yan na sa imo, pabayin lang sa pati. Joke lang. All right, so let's continue with the general rule, no, of for non-metals. Okay, so AB, again, we have a compound here which contains cations and anions, plus C. The C here will be the non-metal or the anion. Okay, so a compound in a single atom or element. It will yield AC. All right, so the cation will be more attracted to the single atom or element which has been interacting with the compound, and also B, which is only an individual ion, anion. All right, so for example, we have barium chloride plus fluorine gas. So now we have barium as the metal, chloride or chlorine is the non-metal, and it will be interacting with this individual gas, which is fluorine, or a non-metal as well. For the chemical formula of barium chloride, we have BaCl2. And for fluorine gas, F2, it is F2 because this is a diatomic molecule. All right, so it cannot stand on its own. All right, so hindi na ka madara maggamugid as long as you are able to see this specific placement or arrangement of our equation, then that refers to single displacement or replacement. Okay, so we have BaCl2 plus fluorine. As we can see on our next slide, fluorine is more electronegative compared than that of chlorine. The reason why that Ba or barium is much more attracted to fluorine this time. Thus, in the product, it will be paired with fluorine, leaving Cl or chlorine as an individual ion. All right, so amo na siya class ang aton nga single displacement or replacement as it happens in our compounds with a metal and compounds with non-metals. Always remember the electrochemical series order, our listing of chemical species. Next, as we have double displacement, or in some other books also replacement. So this is naman involving two compounds. In a single replacement, we only have a compound and an element or an ion or an atom. But in double displacement, we are involving two compounds here. So the general rule is AB, so this is one compound, plus CD, another compound, will yield AD, meaning the cation in when the first compound will be paired up with the anion of the second compound, plus CB, this time the cation of the second compound will be paired with the anion of the first compound. So what happens here is just that they exchanged partner, kumbaga, na? So that's what happens, meaning amuna ning asawa ni A, si B, no? Ang asawa man ni C, si D. Kaso doon nag-exchange lang sila sa ilang mga asawa dira. So malain pagid ini. Okay? So hindi tani pag-obrahon in real life. Example, we have AgNO3. This is silver nitrate. Okay, so NO3 is already a polyatomic ion. Ag is just a single cation. This is silver. And we have NaCl or sodium chloride. This is very familiar to all of you. So as they combine with each other in this double displacement chemical reaction, we have Ag or the cation, silver, will be paired up with Cl. Okay, so it will be more attracted to the negative ion chlorine of the second compound. So in the product, it will become AgCl. Plus, it will also yield another product wherein Na or the cation sodium will be paired up with NO3 or the polyatomic anion in the first compound. So it will become NaNO3. So this will become silver chloride and this will become sodium nitrate. Okay, so that is all about double displacement or replacement. Nga hindi pa pwede nga si Ag kag si Na because there is what we call in the law of our charges that same charge will repel. So there is a repulsion now that will occur if Ag, which is a cation, having a positive charge, and Na having a positive charge as well, they will repel each other. They cannot combine with each other in the product. The same with Cl and NO3. They cannot, both of them are anion, meaning they carry negative charges. There is a law of repulsion, and there is also a force of attraction between these different atoms or ions. All right, are we clear? All right. let's proceed. So this one naman is a very common chemical reaction that most of us have been familiar with since we were a kid. No? So what is a combustion reaction? A combustion is a chemical reaction between a fuel and an oxidant that produces an oxidized product. So this is also known in simpler term as burning. So this is a reaction that usually is between a hydrocarbon. So when we say hydrocarbon class, this is an organic material which is made up of mostly carbon. So it's easily ignited, it's volatile, it's highly flammable, no? So that's example masunog, right? You can catch fire as an instant. So these are our hydrocarbon. Example wood, example atom plastic, no, any other polymers in our environment, okay, even our body, clothing, textiles, no, paper, and a lot more. So those are hydrocarbon and also oxygen. Okay, so when this hydrocarbon was able to encounter oxygen together with the presence of a fuel or heat, then it will yield carbon dioxide, water, as well as it will also release heat energy in the process. Okay, so again, any hydrocarbon plus oxygen will yield carbon dioxide, water, and the release of heat. So example, we have CH4, this is methane. Okay, this is a gas. And also we have oxygen, which is also a gas. Now, when they are together, when they are interacting with each other, that will occur the process of or the reaction of combustion, and it will yield CO2, which is a gas, carbon dioxide, and also H2O, which will also be a water vapor, okay, in the gaseous form of water. All right, so ang ating combustion reaction is easily identified. Why? No, because of course, no, there is always a reagent energy that will occur in this specific type of reaction. And there are three factors that we consider before, actually four factors before burning to take place. We have the presence of fuel, we have the presence of heat, we have the presence of oxygen, and of course, the last factor is chemical reaction. All right, so without chemical reaction, these three specific factors will also begin interacting with each other. That is combustion reaction, and usually this happens, in places or environment where there are highly volatile gases and some other materials. Okay, so I hope that as future seafarers, you will be really aware of your environment, because there are a lot of highly volatile gases and even materials around you, which can start combustion reaction. All right, next is redox reaction. So when we say redox reaction, it is also known as reduction oxidation reaction. It is a chemical reaction where one atom transfers electrons to another. So we can say that redox reaction are common and plentiful, but not all chemical reactions are redox reactions. All redox reaction involves complete or partial transfer of electrons from one atom to another. So as we can remember in our chemical bonding, so these are the forces of attraction that is going on between our atoms or ions. So we have ionic and covalent or covalent bond. Okay, so when we say redox reaction here, we do not actually see or witness it sa aton non-polar covalent bond, because when we say a non-polar covalent bond, there is no partiality. It will always be an equal sharing of electrons, but there is no transfer. So what you need to remember in redox reaction, there is a complete or partial transfer of electrons from one atom to another. Okay, So you might be confused also that there is a similarity, a fine line with ionic bonding, but ionic bonding is only just a result of a redox reaction. Okay, so there again, most of the chemical reaction types that we have already discussed also is a result of redox reaction. All right. So how does this work? It is comprised of two parts, a reduced half and an oxidized half. That always occurs together. They always occur. No? Ang isa gaka-lose, ang isa gaka-gain sang electrons in the process of chemical bonding. Okay, so oxidation occurs when an atom, molecule, or ion loses one or more electrons in a chemical reaction. And when oxidation occurs, the oxidation state of the chemical species increases. Class, you have to remember that when we say oxidation, it doesn't necessarily involve oxygen. It's just that galing gini-use sa, or pangalanan siya, oxidation. Because originally the term was used when oxygen caused some of the electrons lose in a reaction. Okay, so muna siya class nga tawag siyang oxidation. So now let's go to the different evidences that a chemical reaction has taken place. So ari mo obserbahan talang gini, no? Ang aton nga mga evidences. So there is a color or other change. No? So ang baho, ang iyang tsura, malain. And we also have the formation of a gas, no? Mga gas bubbles. Natin kung bubbling siya gani on top of it, then there is a chemical reaction that has taken place. Now, one example naton dira is kita kamusang beroka. Now, ang beroka naton once again, ano mo na siya, it fizzes, no? So ang mga fizz yun na, it also has or the formation of gas bubbles, meaning chemical reaction has taken place there. All right. And also we have other change, no? So that is already given in the first bullet, no? But then again, there is also what we call the light formation. Okay, light formation. And by the way, class, no, we also have the solid formation. No, aring kita niyo ni siya sa figure naton, ang mga yellow na siya nga suspended, no, on the liquid nga portion sang aton nga chemical is what we call the precipitate. Okay, this is a solid part. No, so right after putting a little bit of a, for example, reagent to hasten the reaction, now you can see that there are some occurring solid portions of our chemical substance. It's because that is what we call precipitate. Most of the time, this occurs when there is a chemical reaction that has taken place. And also we have the release or the absorption of energy or heat, no? So ang aton nga temperature will really change when there is a chemical reaction. Okay, so I hope that is clear to all of you, no, about the different chemical reaction types and also these different evidences that will take place when there is a chemical reaction. Let's proceed to the IMDG codes, or when we say IMDG, this is the abbreviated term for the words International Maritime Dangerous Goods. Okay, so you as future seafarer someday, it is really important to know whatever materials they are trying to transport. Okay, so we have here 9 classes of IMDG code classification. What you need to remember is just simply the names, the numbers, for each and every type of codes that we have, and also the symbols, all right, and the color background, the different signs that is being used in order for us to classify each and every code. All right, so we have here explosives, we have flammable gases, non-flammable and non-toxic gases, we have toxic gases, flammable liquids, flammable solids, spontaneously combustible solids or liquids, dangerous when wet. So there are some materials that is really dangerous, no, if or harmful when they get wet. So it's really important to keep them in a or to handle them, no, in a storage wherein they cannot get easily wet, especially you are dealing with water. Oxidizing agents. We also have organic parasites, toxic substances, infectious substances, radioactive materials, corrosives, miscellaneous, and mixed class labels. All right. So some mixed class labels, not one class, no, these are still dangerous, but they don't have, or they are not specifically classified into 9 classes of the IMDG code classification system. All right, so you still know when you get to college, all of these different codes will be more likely specified to you. All right, so let's continue to acids and bases. When we say acids and bases, now these are 2 special kinds of chemicals. It is really important because in our daily life, we are dealing with them. Almost all liquids are either acids or bases to some degree. Whether a liquid is an acid or base, it depends on the type of ions that is in it. If it has a lot of hydrogen ions class, then it is an acid. Of course, we cannot literally know that this is an acid by simply trying to smell it and just say hydrogen ions are here. No, we can also see that in their descriptions, okay, and how manufacturers were able to store them in specific containers. So if it has a lot of hydroxide ions, then it is also a base. Okay, so let's proceed to the different properties of acids and bases. So an acid is any substance that in water solution, it tastes sour. Okay, so may dalawa naman kami gulong ng mga sour, dira ang mga food, fruit or vegetable or whatsoever, meaning it contains a little bit of acidity. Changes blue litmus paper to red. And so litmus paper is actually what we call an indicator in order for us to simply classify whether the specific liquid is an acid or a base. Okay, so again, it has a purple type of purple to blue, no? Meron, makita nga purple to red litmus paper. Actually, when we say litmus paper class, it is made up of the extract of cabbages, red cabbages, okay, or violet cabbages. Naman na siya ang pag-ubra sa atong litmus paper. It is really reactive, highly reactive, to bases and acids. That's why it is used as an indicator whether the specific liquid is an acid, or a base. So it reacts with some metals to liberate hydrogen. So the reason why that when you pour some acids into metallic mga materials, it easily fuses, or it reacts at some point. Okay, and it also reacts with bases to form salts. Okay, so it neutralizes ang aton nga mga base. Okay, and it also promotes chemical reaction, or what we call the acid catalysis. So base in chemistry naman class, is any substance that in water solution is slippery. Kung i-apply mo siya bala sa water solution, it is slippery to touch. So mga anong examples ng slippery to touch? Yung mga sabon naton, detergent naton. So when you apply it in water solution, it becomes slippery. It tastes bitter. So katilaw naman ka mo, samtang pang shampoo ka mo, samtang pang habon ka mo, katilaw ka mo sa habon nila. So accidentally, of course, it is not advisable for you to taste it, but then again, we are able, to, like, ang atong pagin nga, baking soda, that is also a base, okay? Or baking powder natin, di ba, it tastes bitter, so amo na siya class ang aton ng mga base, The only thing that is not, or the only base that is actually not that, or some, there is a level or a fine degree, no, between its acidity and basicity is the milk. Okay, so miski ng water tagani, no, mayroon siya level of basicity and acidity. And also base in chemistry changes the color of indicators like litmus paper red to blue. So amo na siya class ang aton ng differences, no, when it comes to the properties of acids and bases and the common features that we can actually observe by our naked eye and our different senses. Okay. So next is we have here again going back to the indicator. No? So ang indicator naton is we have two. That can be litmus paper, which is a common indicator, and also we have the pH meter. All right, so ang indicator natin, it is used to determine whether it liquid is an acid, no, or a base. Litmus paper is a common indicator because it is mostly used in experiments. So an acid changes blue litmus paper to red, while if it is a base, it changes red litmus paper to blue. All right. Ang pH meter naman natin yung class, as you can see here, the scale na siya, it is from 0 to 14. And the neutral is 7. So if the 0 going to 6 or 6 to 0, that has increasing acidity. Okay, and if the substance, no, is in 8 to 14, meaning it is higher or increasing in its alkalinity or basicity. Okay, no? So ang neutral natin, again, it is just simply 7 or sometimes 6.5. Sometimes our water, no, it doesn't literally touch 7, it's just simply 6.5. Then again, once you round it off, it will just directly go to 7. So diraan na siya natin balan, no, neutral good ang pH level sang aton nga tubig. All right, so you can also make use of this specific scale, no, in order for us to test our acidity or basicity of a substance. So as you can see sa litmus paper ba na natin pa, so paano niyo siya naman gamitin ng pH meter, miss? No? So it is also making use ang aton nga litmus paper. So as you can see, if it's totally so red, no, and ammonia is like orange and reddish, no, it is very acidic. But when it's really, no, from red going to blue or going to purple, it's really so alkaline or basic. So amo na siya class ang aton, no, nga magamit kita sang kumaga aton nga pH meter. So may counterpart sila, no, ni litmus paper kay ni pH meter. All right, so hopefully, no, that you understand what we are talking about here. Next is the same thing, no? So these are just common examples of the different materials that we encounter every day, no, when it comes to their basicity and acidity. Of course, we have here mga soap, detergent, no? Even ang aton nga alcohol, baking soda, no? It has the basicity, you know, even eggs. Ang neutral natin is water. Okay, ang potatoes natin, we have 6, no, and its acidity. Bananas, we have tomatoes. We have no, Heinz, no, tomato sauce. Okay, we have lemon. It has 2 gali, no, manan sa mas lunggid, pero tigid ang aton dira ano. No, ang aton tigid nga hydrochloric acid, this is really acidic, no, and it helps in our digestion. We actually have hydrochloric acid inside our stomach. Okay, so we have, of course, apples or acidic vinegar, no? Sila ang mga acidic naton, yung mga daily or common na ginakaon. No, milk, even milk. No, blood is basic. We have baking soda, na soap, ammonia, drain cleaner, no, na mga examples ng aton yung mga alkaline solutions. All right. So for salts, no, what are salts? A salt is an ionic compound that is formed either directly or indirectly from the reaction between an acid and a base. Okay? So now let's go to balancing chemical equation. It is important if you want to determine the quantities of reactants and products. So a balanced equation follows the law of conservation of mass. An equation is balanced by introducing coefficients, no whole numbers, okay, in an equation in order for us to balance a specific type, no, and know the proportionality of the elements from the reactants going to the products. Okay, so the law of conservation of mass states that before the reaction, the mass of the reactants is proportional to that of the mass of the products. Okay, so that's the law of conservation of mass. No? So wala ikaw nagdugang, wala man ikaw nag-iban. It's just exactly the same. All right, so the coefficients are whole numbers again in front of the symbols or even chemical formula. So here are the guidelines in balancing equations. First, the subscripts of a compound are fixed. They cannot be changed to balance an equation. All right, so again, ang subscript class, remember these are the numbers that indicate the number of that specific atom in a chemical formula. They are fixed and they cannot be changed to balance an equation. Right? No, wala na sila ginabago. Oh, but the coefficient is used, no? Should be the smallest whole number possible. So must start with sa 1 danay. So this is also a trial and error ng process. Number 3, the coefficient multiplies every number in the formula. So for example, we have 2 and A2. So ang 2 naton, no, we will multiply it with the 2 ng subscript. So hindi mo siya ma-change ang subscript, hindi mo siya mahilabtan. But then you can multiply it with the coefficient, no, sang aton nga gindugang dira. All right. So we have here SO4 indicates the presence of 4 atoms of this is 4 Na, 2 atoms of sulfur, no, so 2 Na2SO4, this is Na2SO4 class, no, so 2 multiplied by 2, that will become 4, so 4 atoms of Na, 2 multiplied by 1 in the sulfur, we have 2 atoms of sulfur, and 2 multiplied by 4 in the oxygen, we have 8 atoms of oxygen. So muna siya class, this is the distributive property of multiplication. So in this specific formula, Na2SO4, no, so you have distributed the coefficient nga 2, no, and multiplied it with the different, no, number of atoms that is already indicated in that specific chemical formula. All right, so diri sa ating figure, we have CH4 plus Cl2 will yield CCl4 plus HCl. So what will happen, no, is we have to know first the different elements that is indicated here in the reactants. We have C, arisa, no, may CD, may C, diri ang C lang gid, carbon, that is carbon, no? We have H, that is hydrogen, and we have Cl. No, so dapat kung anong ari din ang mga elemento, dapat ari man na di siya sa aton nga produkto. Okay, so we have C, carbon, hydrogen, and chlorine. Next is we have here in the reactants, and the products rather, we have C, carbon, and we have, this one is H, no, or for hydrogen, and we also have Cl, no, for chlorine. Okay, so what will happen, class, no, is we have to know first the number of each and every element. We have for carbon, we have 1, hydrogen, we have 4, and Cl, we have 2. Okay, may idala na si 4, no? And then in the reactant side, in the product side, we have carbon, also 1, hydrogen, we have 1, and chlorine, we have 1, 2, 3, 4, 5. So 5 na sila, class. Okay? So what will happen next? No? Is that we will add a coefficient. Pangitaon to kung sinong hindi balance. May 1, 1 kita into carbon, right? So, balance na siya. Hydrogen. So, sa kay hydrogen, may 4 kita dere. So, which means, ang kulang nga 4, dere kita ma-add kay hydrogen sa atom products. No? So, i-multiply ito siya by 4. Dugang to 4, hindi ka na magagi sa 1, 2, 3. Kaya 4 ang kinahanglan mo, no? For hydrogen. So, 4 multiplied by 1, that will become 4. So, balance na si hydrogen ta? Yes or no? Oh, yes. No? So, 4 hydrogen, 4 hydrogen. Next, take it with may 4 kuti, distributive property gani, no? We will multiply it also with our chlorine. No? So, 4 multiplied by 1, no? So, ang chlorine, ta class by the way, class ha, ibutangan mo na di siya kung gasala, gig ka mo, butangan yun, di siya another chlorine. Iti duwa itong chlorine mo, di ba? We have Cl4, pag we have Cl also, no? Nga may 1. So, diri, para hindi mo magsala, no? So, diri 4 na di siya, Cl, diri, another 1 kita. So, 4 multiplied by 1, that will become 4. Okay, so may 4 kita nga Cl, diri kay HCl, may 4 man kita nga Cl, diri kay CCl. Okay? So, ang duwa ka Cl, once you sum it up together, no? Cl4, pag Cl4 man, 4 plus 4, it will become 8. Alright, so ang Cl ta diri, 8. So, ang Cl ta diri is, in the beginning, it's 2. So, ano ang pupwede mo? Ma-multiply kay 2, that it will become 8 and it will be balanced in the product side. So that will also be 4. So 4 multiplied by 2, that would become 8. So balance na, we have 8 chlorine atoms in the reactants and we have 8 chlorine atoms in the products, 4 hydrogen atoms in the reactants and 4 in the product. We have 1 carbon atoms in the reactants and also 1 in the product. Thus, this is the balanced equation for CH4 plus 4Cl2 is 2CCl4 plus 4HCl. Okay? So, muna siya class ang aton nga balanced equation. That is the end of our lesson, no, which will be the second to the last topic, no, for our chemistry. For the next video and recording, most probably we will tackle about stoichiometry and naming binary and ternary compounds. Thank you very much for listening, and I hope you have learned something today. God bless you all.